In this video, we're going to solve equations with exponential and logarithm functions. And the first example we're going to look at is example 1. Solve the following function for x, giving your solutions in exact form. E to the power of 2x minus 5e to the power of x plus 6 equals 0. So we'll take a look at that. We have e raised to the power of 2x minus 5e to the power of x plus 6 equals 0. And this looks somewhat like a quadratic equation, but it's not actually a quadratic because it's e to the power of 2x. So if we let u equals e to the power of x, well then we can rewrite this in terms of u squared minus 5u plus 6 equals 0. So we have a quadratic equation in u, and we can factor this one to solve for u. So we've negative 5, which will give us, say, negative 3 times u negative 2 equals 0. And the solutions for u could be positive 3 or u equals positive 2. So we have two solutions for u, but we know e to the x is u. So e to the x is positive 3. And when we have the unknown in the power, well then we'll take ln of both sides. So ln e to the x equals ln 3. Now we take this x down from the power using our rules of powers. X ln e equals ln 3. But ln e is 1. Log ln is log base e. So log base e of e is 1. So we have x equals ln 3. So that's one solution in exact form. Now, similarly, we had e to the power of x equals 2. And following the same process, we will get x equals ln 2. So our final answers in exact form are given there, ln 3 and ln 2. So we'll take a look now at the next example. So in example 2, state for which values of x the following logarithmic equation is defined, and then solve the equation. So we have 2 log base 2 of x minus log base x of 2 equals minus 2. And just going over to the pad, so example 2, we have 2 log base 2 of x minus log base x of 2 equals negative 2. Now we're told, well, we know that these are different bases. So, well, the first thing actually we need to say is this log is defined when x, for any value of x greater than 0. A log can never take a negative value, so x must be greater than 0. We need to change one of the bases. We've got log base 2 of x and we've got log base x of 2. So I'm going to change the base x. Leave this one log base 2 of x minus. Now I'm going to change the base, use to base 2. So it's going to be log base 2 of 2 divided by log base 2 of x equals negative 2. And continuing to simplify that, we've 2 log base 2 of x minus 1 over log base 2 of x equals negative 2. Now at this point it might make it easier if we just call log base 2 of x maybe y. So let y equals log base 2 of x. And we're going to write the equation in terms of y. 2y minus 1 over y equals negative 2. Now, in order to solve this, I can make it a quadratic equation by multiplying across by y. So I have 2y squared minus y over y equals negative 2y. Now I'll simplify that again so we have it in the form that we can solve. So I have 2y squared plus 2y minus 1 equals 0. Now I'm going to need to find solutions for y, so let me just take up the calculator and do this using mode equation 5 and 3. So this is if you don't have this function on your calculator, you can always do this problem using the quadratic formula. 2 is the first coefficient, the second coefficient is 2, and the third coefficient is minus 1. So we'll get a third value for y, and I'm just going to decimalize that to give me the first value for y. So 0.366, we'll call it 0.37. Just round it to 0.37 is the first value for y, and the second value for y is, it's a negative probably, it's a third again, we'll just decimalize it, negative 1.37. Now we know that we said y equals log base 2 of x. So in the first case we had 0.37. Well, we can basically go x equals 2 raised to the power of 0.37, not x, that should be y. Just delete that out. So y will be 2 raised to the power of 0. Excuse me, that is, if we have y equals 0.37, well then x equals 2 raised to the power of 0.37, and the second value of x we might get is x is 2 raised to the power of negative 1.37. So let's take a look at those on the calculator. We'll go back to mode 1, and we have the first one is 2 raised to the power of 0.37, and we get a solution for x is 1.29. We'll just say approximately equals 1.3, and the second possible solution for x is, let's go back and delete. So we're going to put in negative 1.37. So 2 raised to the power of negative 1.37 is giving us x equals 0.39. 0.39. So there are two possible values. Both of those are greater than 0, so we can accept both of those answers for x. Okay, let's look at the last example in this video, and the last example is for what values of x is the following logarithm defined, and solve for x. So we have log base 4, 3x minus 1 plus log base 4 of 2x plus 1 equals 2. So we'll just go across and take a look at that problem. So first of all, I write the problem was log base 4 of 3x minus 1 plus log base 4 of 2x plus 1 equals 2. So this log is defined when what's inside the log, 3x minus 1, is greater than 0. So we can rearrange that to say 3x must be greater than 1, or x must be greater than 1 over 3. And the second log is defined when 2x plus 1 is greater than 0, or 2x is greater than negative 1, or x is greater than negative 1 over 2. So those are the conditions under which this log problem is defined. So now we'll take a look at solving the log problem. So we know using our rules of logs, on the left we can make this log base 4 of 3x minus 1 times 2x plus 1 equals 2. Now I'm going to say 2 log base 4 of 4, because that in effect is bringing the right hand side in terms of logs. So we'll have on the left log base 4 of 6x squared, and we'll have plus 3x minus 2x is plus x, and minus 1 equals log base 4 of 2 squared, of 4 squared. 4 squared is 16. So we can now equate what's inside the log. So we've log base 4 on the left and log base 4 on the right. So I can actually therefore say 6x squared plus x minus 1 equals 16. And I'll continue this problem. We can solve this quadratic problem by writing it as 6x squared plus x minus 17 equals 0. And again, in this case, I'll use the calculator to get my two values for x. So my two values for x, go to mode 5, 3, and the first coefficient is 6. The second coefficient is 1. The third coefficient is negative 17. And we'll get a solution. The first solution, again, it's in third form. I'm going to just write it in x is 1.6, just rounding it. Or the second value of x could be negative 1.7. Now I need to just take a look at when these two logs were defined. So we have to look at x must be greater than, if we look up here, x must be greater than negative half. Well, this value here must be rejected. So the final answer is x equals 1.6. And that's it for this current video, and thank you for watching.